Hey, let's go ahead and continue on here. So number 8, convert to degrees. So hopefully your teachers talked about in detail about radians and degrees. So I'm gonna just, okay, it's a really bad circle, sorry. Okay, so let's say we start from this and we start going clockwise. Okay, so this would be 0 degrees. Right up here would be 90 degrees, right? If we went and talked about this little arrow to here, we've covered 90 degrees. And if we keep going around, we would get to 180 degrees, and we keep going to 270 degrees. And of course we finish, one full rotation would be 360 degrees, okay? Well, without getting into too technical about radians, it's a very important measurement. You use it almost exclusively in higher level math. And I can't really I don't have enough time to go into all of where it comes from and why it's important and why it's really simple compared to degrees. But let's just give you the basics of it. Okay, so in radians, this is 0 radians if we start the same thing. Okay, if I go halfway around, okay, 180 degrees is pi radians. And then if I finish all the way around, okay, well, if 180 is pi, of course, it's pi for the next 180, so it's 2 pi. So in radians, these are the important things to remember. I mean, you could also remember 90 degrees is pi over 2 radians, 3 pi over 2. But at this point in your career, the most important thing is to understand these. So when we're saying convert to degrees, okay, we're going to use one of these conversion factors. Okay, 360 for every 180 degrees is to pi. Okay, all right. So how are we going to get this? Convert this to degrees. When we go, this is in radians as we speak. Here, radians. And an easy way to tell that is because it has the pi attached to it. Okay, so we want to go from radians to degrees. So radians, I have my 7 pi over 4. And I'm going to multiply it by a conversion factor. Okay, and this is going to be the one that I'm going to use, right? Right, 180 degrees over pi. Okay. So what's going to happen are those are going to cancel. Okay, this, again, you can simplify it any way you want. So like you can think, 2 goes into both of these, right? And then go, oh, hey, it also goes in again, 45. Okay, so the conversion is 2 degrees, starting with our 7 pi over 4 equals whatever 7 times 45 degrees is. I'll let you do the math on that. Okay, so that would be our degrees. Okay, all right, if I wanted to go the other way and I were going from, let's say I said I want to go 30 degrees, and what is that as radians? Well, we do the same thing, but here we're multiplying. We wouldn't be multiplying by 180 over pi. We would have pi over 180. Remember, if we want it in radians, if we want something in radians, remember, we've got to have, at the end of the calculation, pi's got to come out at the end, okay? So we just flip that pi and that 180, because, see, this is going to cancel. That's going to be 6, okay? So I'm going to have pi over 6 radians, okay? So the important thing is this conversion of pi 180 or 180 over pi. Okay. All right, let's okay, so I was looking at this. Oops. So I was looking at this on the regular a regular octagon. Okay, anytime we have a regular polygon of anything, okay, a regular polygon is made up out of isosceles, isotriangles. In this case, since it's an octagon, we have 8 congruent, the exact same size, congruent isotriangles. Okay, so I'm going to take this, I'm going to go ahead and redraw it over here. Okay. So it's doing this right here, okay, and we're saying this length right here is 12, okay. Now, if I want to find the area of the regular octagon, what I really need to find is the area of this isosceles triangle, okay. And really, I really just need the area of this right triangle, because I can just multiply that by 2, can't I? Yeah. So I really want the area of this, and the area of a triangle is 1/2 base times height. Okay. So I need to know this here, this height, which, by the way, in an octagon would be the apothem here. So I'm going to put A, but that's just the height of this right triangle. And then we're going to call this our base here. Okay. So again, I'm going to redraw this again, okay, just to really be as clear as possible on what we're talking about here. So this B here, and this A, and this 12. So I want to be able to figure out A and B, okay? And to do that, I'm going to need to know their lengths. And to do that, I need one more little bit of information. I need to know an angle, this angle. This angle comes from this up here. This is the central angle for this here, okay? Which, remember, since there are 8 congruent triangles, there's 8 of these in this. Here, let's draw 8. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so I need to know what's each one of those angles. Well, it's 360 degrees all the way around. So we take that and divide it by, well, there's 8 triangles. Okay, 360 divided by 8 is 45. Hopefully I did that right. So we come back. Is that right? Here, my brain is shot right now. Yes, it is. Okay, so 45 degrees, so that's 45 degrees, that means this angle here is 45. But remember, what I really want now is over here, this theta right here. So that's half of that, because that right triangle is half of that isosceles. So that means this angle is 22.5 degrees. So now that I know that, I know what A and B are, because I can just use trig. Okay, so let's find out what B is. Well, B is the sine of 22.5 is the opposite B over the hypotenuse 12. So B is 12 times sine of 22.5. Okay, so that's my B. Okay, how about my A? Well, we're looking for this adjacent side to that angle, so that's going to be our cosine. Cosine of 22.5 is our adjacent side, that's our A, over 12. So for our A, we're going to have 12 times, cosine of 22.5 equals A. Okay, so now that I have that, if I want to know the area of this triangle, right, area is 1/2 base times height, or A times B, okay, and now I can just plug this stuff in, right? Once I plug this in to here, I've got the area of this right triangle. So then I have to multiply it by 2 to get the area of one of those isosceles triangles. So once I get that one this octagon, I just multiply by 8. Okay. So to go back real quick, right? That's why they gave you this little right triangle here. They're trying to give you the hint that it's all about a right triangle. You need to find this little A and this little B, and it all comes down to finding this angle here, which we can then use to our little triangle trigonometry here to find those two sides, A and B, and then work our way all the way back to the beginning. Okay. Okay, let's see, I think we have... Okay, another one with a regular pentagon, okay? And it says the apothem of 5. The apothem of 5, again, for this, it's giving us this height here. So now it's giving us this right triangle, okay? I'm going to redraw this right triangle, saying this is 36 degrees, there's our right angle, and this is 5. So we already have the height of this, so we just need to know this opposite side here, okay? And that's going to be the tangent of 36 degrees, because again, just triangle trig, because we have opposite over the adjacent is opposite, so this is what we want, over our adjacent we know is 5. So we do that, it's going to be 5 times tan of 36 degrees is this opposite side. Okay, so now that we know that, whatever, here, might as well go ahead and calculate that real quick. 5 times tan of 36. We're just going to round it to 3.6 for now. Okay, so this opposite side here is 3.6. So this triangle is 1/2 base times height. That's the area of this right here. Okay, so when we double that to get to here, so we're going to take that and double it. Okay, basically what's going to happen is those are going to cancel, right? Okay, now I have this is the area of one of those, and I take that and just multiply by 5. And that'll give me the area of the whole thing. Okay, last but not least, this is actually a pretty simple problem, because it says the perimeter. Well, the perimeter is just this length here, this length here. Well, that's 50, that's 50. So there's 100, and those are the two straight sections. Then I have this and this, which turns out just to be a single circle, because these are both half circles. And if I see that this is 60 yards long, that means the radius is 30. So plus the circumference. The circumference is 2 pi r. So it's 60 pi. So plus 60 pi. So that's our perimeter. Our area, well, coming back here, I have an area here of this rectangle, which is 60 by 50. It's that 300, or actually 3,000. Okay, and then I have these two, which is just a single circle. So I have the area of this plus the area of that circle that has a radius of 30. So we would just use area equals pi r squared. Okay. Sorry, I'm going to cut this quick because I have to get this in under the 15 minutes for this video. So, all right, we're all done.